Hi everybody, we're going to continue our discussion on the unit circle, so make sure you have that document open or out, and we're going to look at some more information with the circle. Okay, so what I'm looking at here is an actual problem out of the book. I just named it A, but it's question 51 in the book. You don't have to copy it down, just definitely you want to evaluate the 6 circular function values of theta, and you should at least write letter A and number 51. Okay, so here's what I have. I have a circle. Again, you can look at this in the book on question 51. I believe it's on page 117. Page 118 would be where you'll find it. And we're looking for the 6 trig function values, the circular function values, sine, cosine, tangent, and then the other 3. Okay, so I'm going to go ahead and write that down, and then we're going to fill in each one of those values. Okay, so the first function that I'm looking for is the sine. According to this chart, which is on page 110, it's also with your unit circle, the sine is always the y value. So an easy way to do this would be just to kind of mentally visualize which of these points is the x and the y. So it's always x and then y. So the sine would be this one right here, which is square root of 2 over 2. The cosine is always the x value. So that means it's going to be square root of 2 over 2. This one just happens to be the same thing. And the tangent is going to be the y divided by the x. So make sure you're picking the y first. They're not usually going to be the same numbers like they are in this one. I have to put the y first. So it'll be square root of 2 over 2 divided by the square root of 2 over 2 because it's y divided by x. Okay, now I can't leave it like that. I need to simplify the fraction, and then I'm going to have to rationalize probably the denominator. Maybe, maybe not. The rule of algebra says you are not allowed to divide something by a fraction. Instead, you have to multiply by that reciprocal of that thing I'm trying to divide by. So you keep the top, flip the bottom. So I'm not going to be able to divide by this number. Instead, I'm going to have to multiply by its reciprocal. Keep the top, flip the bottom. So this one I'm flipping. If it helps you, you can put a little note to yourself that you're keeping this and you flip that bottom fraction. So instead of square root of 2 over 2, it's going to be 2 over square root of 2. Now, think about whether you can simplify this. There are some things that will divide out. When you are multiplying, no equal sign here, when you are multiplying fractions, you would multiply the square root of 2 times 2 and then 2 times the square root of 2. But you should notice that these 2's will actually divide out. And these square root of 2's will actually divide out. And so what you're left with is the entire thing is just equal to 1. So this tangent of theta is just equal to 1. Okay, now I need the other 3 trig functions. If you can't remember what goes with what, I can kind of take a peek at this. Sine and cosecant go together, cosine and secant, and then tangent and cotangent. Okay, so sine and cosecant go together, cosine and secant, and then tangent and cotangent. We could use the information in the chart or just do the reciprocals. So if you remember back to chapter 2, we flipped them over and then rationalized if needed. Square root of 2 over 2 would be 2 over root 2. Same thing for the second one, 2 over root 2. This is 1, the reciprocal would just be 1. I need to rationalize. These two are exactly the same, so I'm going to rationalize the first one, and then I'm just going to write down that same answer. Okay, so I have to multiply by the square root of 2. So that gives me 2 root 2 over 2. But what you should notice here is that you have a 2 in common on the top and the bottom. Those will actually divide out, and you're just left with the square root of 2. This is identical. So I'm just going to write the answer square root of 2. See how these were the same? Okay, so you've got all 6 circular functions. In this one, you can see that this is number 52 from the book. You can just call it letter B and write 52. You don't have to draw the circle. Negative 15 over 17 and 8 over 17 are given. Okay, so I'm going to label them X and Y. And I need to find the 6 circular functions, sine, cosine, tangent, and then we'll find the other 3. Okay, I'm using my chart here. It says that the sine is equal to the y. So if I look at my circle, that's the x. This is the y. Okay, so y equals 8 over 17. So my sine of theta, the sine of this angle, is 8 over 17. The cosine of the angle is the x. So the cosine of this angle is negative 15 over 17. The tangent is the y divided by the x. So make sure you write your y first. Be careful when you're writing this out. It's going to be 8 over 17 divided by negative 15 over 17. And again, I'm getting these values from the x and the y up here in this picture. I cannot leave that as 8 over 17 divided by 15 over 17, negative 15 over 17. So I'm going to have to simplify it. You're not able to divide by a fraction. Instead, you multiply by that reciprocal of that fraction there that you're trying to divide. Okay, so I'm going to multiply by the reciprocal. Keep the top. That one stays. And you're going to find the reciprocal of the bottom, you know, like flipping it. Reciprocal, you're just flipping it over. Okay, so instead of negative 15 over 17, I cover up the negative, I flip it over, and then put the negative back in front. So negative 15 over 17 would be 17 over 15. And then I'm going to put the negative back in front. Cross out anything that you can. The 17s actually divide out. That leaves you with ones. And then 8 and 15, those stay. Okay, 8 times negative 1 would be negative 8. And 1 times 15 is 15. Okay, so my tangent is negative 8 over 15. Okay, now I need my other 3 trig functions. That would be the cosecant, the secant, and the cotangent. Remember, these are going to be reciprocals of the original. Instead of 8 over 17, it's going to be 17 over 8. Instead of negative 15 over 17, cover up the negative, flip it over, put the negative back in front. So it's going to be negative 17 over 15. And then finally, instead of negative 8 over 15, it's going to be negative 15 over 8. Okay, now what I'm going to do is I'm going to find an angle when I'm given the trig function value. So in these last questions, we were finding the trig function value, all these values on the side. Now you're going to be given a trig function value and you're going to find the angle that they're talking about in the problem. Okay, so here's what it says. It says you are given an interval and you're looking for the given circular function value. I'm sorry, you're looking for the angle that has the given circular function value. Okay, this says to look between pi over 2 and pi. What is that? Oh my goodness. So if you look for pi over 2, you will see that pi over 2 is actually 90 degrees. Then it says to go up to pi. What's pi? Well, let's find it. Pi is 180 degrees. Oh, that should sound familiar. We've been working with that. Okay, so these directions are telling you to look at the circle between 90 and 180. And you're looking for an angle that has the sine of 1/2. Okay, so we're looking for some angle that has a sine of 1/2. The sine, according to our little chart here, is the y value. So we're going to be looking at all of the y's as we move around the circle. Okay, so this is a y. Is it 1/2 though? You should say no. Look at this y. Is it 1/2? No. Is this y 1/2? No. Is this y 1/2? Yes. Okay, so this is the angle right here that has a sine value of 1/2. That angle is 150 degrees, but since your book writes it in radians here, it's asking you to provide the radian measure, which is 5 pi over 6. So really what you're doing in these questions is you're just going in the opposite direction. You are given the trig value and you're giving the angle where that occurs. Okay, so same idea on this one. I'm looking for some angle between pi and 3 pi over 2 that has a tangent value of square root of 3. So what is pi? Well, pi, as we saw in the last example, is 180 degrees. So it means I'm starting at 180 and I'm ending at 3 pi over 2. So if you look at the bottom of your unit circle, you'll see that 3 pi over 2 is right here. That means 270 degrees. So I'm looking at this quadrant down here, which is quadrant 3, and I'm trying to find some angle that has a tangent of root 3. This circle is just the basic unit circle and does not have any of the tangent values on it. I have to calculate it. But if you look at the circle that I gave you, you will see that I have the tangent values on here for you. All of these numbers on the outside of the circle are the tangent values. So it goes cosine, sine, tangent, cosine, sine, tangent, all the way around the circle. Okay, cosine, sine, tangent. So I'm looking at this quadrant down here, according to what we just decided. The directions tell you to look from pi to 3 pi over 2. So we're looking at quadrant 3. So I can look down here at quadrant 3, and I'm looking for one of these tangent values, the numbers on the outside, that is equal to the square root of 3. Okay, so let's look at each one and decide if it's square root of 3 or not. Okay, so this is not square root of 3. This is square root of 3 over 3, but that's not what I'm looking for. This is not square root of 3. Aha, right here. See this? Square root of 3 actually goes with this set of angles. Now, I got a little excited, looks like, with my letter y there. That's just an x, that's a y. These are not negative. None of these should be negative here. This is just 240 degrees, and it's 4 pi over 3. So that should not be a negative there. That's just 4 pi over 3. Okay, so I'm going to write that down. 4 pi over 3. The reason I'm putting 4 pi over 3 and not 240 degrees, which you could also, is that the book is asking you for radians because it gives you the range in radians. Okay, if you do want to write both of them down, that is perfectly fine. Here's the assignment set, and I want to do number 55 with you. Okay, when we're doing these, we're looking for the value of S. S, when you were doing these, was the angle. So for number 55, we're finding the angle. This is not on the unit circle. So this is not like the one we just did where we could look it up on the circle. So for these, you're finding the calculator approximation. So you're going to use the calculator. Okay, I'm going to bring down the letter S. That's what I'm trying to find. I'm going to use the tangent. That's what's given. And anytime you're looking for an angle, S is the angle, that's what's missing. That's when you do the inverse of the tangent. Okay, so I'm going to take this number and I'm going to bring it down. And I'm going to type this into my calculator. Make sure you are in radian mode when you type this in. These are still radians that we're working with. To type in this inverse tangent, I'm going to type second and then tangent. Okay, so I'm pressing the blue second button, and then I'm going to press tangent. If you look above the word tangent, you will see that that's that inverse, and that's what I just got. Now I'm going to type in 0.2126. Hit enter, and I'm going to round it off to 4 decimal places, so 0.2095. If you want to write radians, you can, but I'm just going to write 0.2095. They didn't write radians in the answer key, but this is a radian measure. Have a great day.